All right, we're going to cover lessons 22 and 23 in this video. We're going to be talking about fractions with radicals or dividing with radicals. Remember, a radical just means a square root symbol or cubed root or fourth root. Here's the thing, mathematically, it is illegal to have a radical symbol in the bottom of a fraction, which means you cannot divide by a square root. However, you're going to be given problems that will have a radical in the denominator or ask you to divide by a radical, and you have to figure out a way to do it. So today I'm going to show you. So let's jump in. So here's a question. You're going to see something like this. 4 over square root of 7. And remember, a fraction means just division. So what we're really being asked to do is divide 4 divided by the square root of 7. And if I enter that, I'm doing it right now, in a calculator, it's going to say error if I use the fraction key. If I do the division key, it's going to give me a decimal. Okay, but here's the thing. You're going to need to leave this in fraction form. So let me show you how to do that. So do not simply type this in your calculator because it's going to give you a decimal, and that's not what we're looking for. Let me show you the way your answers should look. Okay, the rule is to eliminate a radical symbol. I simply multiply by itself. Now let me explain what that means. This denominator has square root of 7. If I multiply the square root of 7 times the square root of 7, what I get is the square root of 49, and the square root of 49 is 7. Okay? Here's what I need you to understand. When I multiply a radical times itself, it always becomes the number that's under that radical. All right? So I'm going to multiply, let me clean all this up. I'm going to multiply everything by itself. Now here's the second thing I have to remember. Whatever I do to the bottom of a fraction, I have to do the same thing to the top. So what I'm going to do, let me stretch this out a little bit. I'm going to have to multiply the bottom by the square root of 7 so that simplifies down to simply 7. Square root of 7 times the square root of 7 is 7. But the rule is whatever I do to the bottom, I have to do the same thing to the top. 4 times the square root of 7 is simply 4. So that glitched out. I don't know what happened, and I don't want to re-record that stuff that I've already done. So let's kind of rewrite part of this. Square root of 7 times the square root of 7 is 7. We already discussed that. 4 times the square root of 7 is 4 square root of 7, not 4 like I previously wrote. And this is as far as I can simplify this down, so that becomes the answer. Listen to me. If you simply type this in your calculator, you're going to get a decimal, and that's not going to be an option on the homework section of this, so you need to know how to do this by hand. All right, let's look at another one of these. You have 5 square root of 2 over the square root of 6. Okay, I have to eliminate my radical symbol in my denominator. So to do that, I multiply it by itself. Whatever I do to the bottom, I have to do to the top. Square root of 6 times square root of 6 simplifies down to simply 6. 5 square root of 2 times square root of 6 is 5 square root of 12. Now here's where this can get a little tricky. I have to simplify this. And remember, when we simplify that, we break it into its prime factors. So the square root of 12 can become 12 divided by 2 is 6. 6. Any pair pulls out as 1. Five times 2 is 10. Square root of 3 over 6. All right, so my radical is now simplified, but the next thing I have to remember is I also need to simplify any of my fractions that I have. 10 and 6 can both be divided by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. And this is my answer. So let's go through a couple more of these because there's a lot of steps here. Number 1, I got rid of my radical in my numerator, in my denominator, by multiplying it by itself. Then I have to simplify the radical. Then I have to simplify the fraction. So let me write those steps out for you, and you might want to write those down in your textbook. So here are the 3 steps written out, and it probably explains this in your textbook, but I would write this down if I were you as a sort of a quick reference. Your first step is going to be to multiply by the radical in the denominator in order to eliminate the radical in the denominator. Then you're going to simplify that radical. Then you're going to simplify the fractions. Let's do a couple more of these so you can see those steps kind of in action. So let's do another one of these. Let's say I give you 5 over the square root, 5 square root of 2 over the square root of 12. Okay? Step 1, I cannot have a radical in my denominator. So I am going to multiply by that denominator to eliminate my radical sign. Because remember, a square root times itself eliminates that radical sign. So square root of 12 times square root of 12 simplifies to 12. 5 square root of 2 times the square root of 12 is 5 square root of 24. So step 1, multiply by the radical to eliminate the radical. Step 2, we've got to simplify this. There is not a solid square root of 24. So I'm going to tree it, and then I'm going to pull out any pairs that I've got. So 24, breaks down into 2, 2, 6, 2, 3, 2, 2, 2, 3. Of course, all over 12. This pair of 2's is going to pull out as 1. Whatever's inside stays. 2 times 3 is 6 over 12. 5 times 2 is 10. So, step 2, I've simplified my radical. Step 3, I've got to simplify my fraction. I can reduce that. 10 and 12 can both be divided by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. And that is my answer. So multiply by the radical, simplify your square root, simplify your fraction. Now, things change a little bit when it's not a square root in the denominator, which would make sense because a square root is 2 of something. So if I have a cubed root, that means there's going to be 3 of something. So I need to kind of pay attention. Now listen, your textbook shows you this really strange, at least I thought it was strange, formula to memorize. There is no need to work through a formula for this, but let me just explain something. Remember the first one we had square root of 7. And we multiplied it by itself, because the square root is 2 of them. So instead of using this weird, crazy formula that they've got, here's what I need to remember. Cubed root means that there are 3 of them. So what I'm going to need to do is I'm going to multiply 1, 2, 3. I need 3 cubed root of 12s to eliminate a cubed root. If it's the 4th root, I would need 4 of them. If it's the 5th root, I would need a total of 5 of them. And remember, whatever I do to the bottom, I'm going to write this real small, but I'm going to rewrite it. Whatever I do to the bottom, I do to the top. So pay attention, if it's a square root, I only need a total of 2. If it's a cubed root, I need a total of 3. So when I rewrite this, cubed root of 12 times the cubed root of 12 is the cubed root of 144. Cubed root of 12 times the cubed root of 12 times the cubed root of 12, I have 1, 2, 3 of them. That counteracts it, and I'm left with just 12. So pay attention if it's a cubed root or a fourth root. And remember, however many I need to multiply the bottom, I have to do the same thing to the top. Now I need to simplify my cubed root. So if I break up 144, let's see, that's a 3 by the way, let me fix that. Let me pull up my calculator to figure this one out. I know it's even, so 144 divided by 2, then I'm going to divide it by 2 again, gives me 30, that's not the right number. That gives me 36, I'm going to divide that by 2 again, which gives me 18, divide that by 2 again, that gives me 9, which is 3 times 3. Now let me double check that math, 2 to the 4th power times 3 squared, 144, perfect. Now, in a square root, 2 of something pulls out as 1. In a cubed root, 3 of something is going to pull out. Okay? There's my 3 I started with. The 2 3s are going to pull out, and then whatever's left inside, I'm going to remultiply. I don't need a symbol that big, but 2 times 3 times 3. 2 times 3 is 6. 6 times 3 is 18. That's still over 12. Don't lose that. 3 times 2 is 6. Oh, cubed root. My bad. Over 18, over 12. Now, 6 over 12 can reduce, and I'm out of space. 6 over 12 becomes 1/2. So, that's terribly written. All right, let's work where we have some more space. 6 cubed root of 18 over 12. 6 over 12 can reduce to 1. Cubed root of 18 stays over 12 divided by 2 is 6. So this is going to be my answer. All right, so these are just going to be a little bit weird as you start through them. So pay attention. Don't get bogged down in all of the steps. Focus on one step at a time. What happens so many times is students try to look at the whole picture and they get bogged down and they get mixed up. One step at a time. Step 1, multiply by the radical. If it's a square root, we need 2 of them total. If it's a cubed root, we need 3 of them total. And then whatever you do to the bottom, do to the top. So step 1, simplify radical, or multiply by the radical to eliminate it. Step 2, simplify your radical, find your pairs. Step 3, simplify the fraction. Let's do another one. All right, let's do another one that's not a square root. Where's my pen? Here we go. 5 over the 4th root of 15. I'm making this up, and it may be a horrid mess. We shall see. All right, if it is the 4th root, that means I'm going to need a total of 4. So there's 1, 2, 3, 4. Whatever I do to the bottom, I do to the top, which means I need 3 of these on the top. Oops, I wrote a 3 as I said a 3. 4th root of 15. And this is going to get tedious. And of course, you may not need to write all of this down. My visual brain absolutely has to. All right, I know that my bottom now is simply 15 because it's the 4th root. And I have a total of 4 of them. That radical symbol just goes away. On my top, my whole number is still 5. And then I'm going to have the 4th root of 15 times the 4th root of 15 times the 4th root of 15. Oh, goodness. That gives me the 4th root of 3,375. So let's see if I can simplify this down. 3,375 can break down to, I'll do it on my calculator, 3, 3, 3, I believe. Let me double check this. 5 times 5 times 5 times 3 times 3 times 3. So the reality is, this is a bad example. That can't simplify any because there's no pairs of 4. I have to have 4. So this whole ugly mess is my answer, okay? I really just wanted you to see this part one more time because the simplifying is not quite as complicated. You might see these problems written like this. Here's what you need to remember. A fraction line is the same thing as a division line. And so really, this is the exact same type of problem. But what I'm going to do in order to make this easier, usually we want to eliminate fractions, but we are actually going to write this as a fraction to make this a little easier. All right. Remember, it is not acceptable, mathematically illegal, however you want to think about it, to have a radical in your denominator. You can have a whole number. So in this case, the 3 down here is fine. What I have to get rid of is the square root of 2. So to get rid of the square root of 2, I'm going to multiply by square root of 2, and whatever I do to the bottom, I have to do the same thing to the top. That 3 is a whole number. It's perfectly fine to stay there. So my new top is now 8 square root of 12. Square root of 2 times square root of 6 is square root of 12. And then this 3 stays there, and this square root of 2 times square root of 2 becomes 2. So what I really have is 8 square root of 12 over 6. Now I need to simplify my radical. My 8 stays put. 12 can be broken up into 2 times 6, which is 2 times 3 over 6. Because it's a square root, I need a pair of 2, and it pulls out as 1. Whatever's in the radical stays. I'm going to run out of room. 8 times 2 is 16. Square root of 3 over 6. And now if I need to simplify, or if I can simplify, I need to do so. 6 divided by, 16 and 6 can both be divided by 2, which gives me 8 square root of 3 over 2. Over 3. Don't know why I wrote a 2 there. Over 3, and this is my answer. Let's do one more of these. I'm going to rewrite it as a fraction. Now remember, I have to eliminate the radical. I can leave, that's a terrible 12. I can leave the 3 there because it's not under a radical sign, so it's fine. The only thing I need to eliminate is the radical sign. All right, so this is now going to give me on the bottom 3 square root of 12 times square root of 12 is 12. On the top, I'm going to have my 9, that's still there. Then 2 times 12 is 24, which gives me 9 square root of 24 over 3 times 12 is 36. So let's simplify that square root of 24. 24 is 2 times 12, 12 is 2 times 6, and 6 is 2 times 3. If I did that correctly, I always double check when I do it in my head when I can. That's 24 over 36. A pair of 2's is going to pull out. So that gives me 9 times 2 square root of 6 over 36, which is 18 square root of 6 over 36. And 18 over 36 can reduce. It goes all the way down to 1/2. So I have 1 square root of 6 over 2. And that is my answer. Listen, this lesson is really hard, and I despise having to do a lesson like this long distance. So what I'm going to have you do is I'm going to have you do activity 2 on both lessons 22 and 23. It's really not that many questions, maybe 4 per lesson, I think. And then I want to be able to check these when we're face to face again, and if we need to go over any specific questions, because there's a lot of steps in this. The math of this isn't hard. You're doing simple multiplication, simple prime factoring, and things like that. There's just a lot of steps in here. So you do not have an online quiz for this, okay? I need you to do activity 2 from lessons 22 and 23.